Hey, Tyler.
Hey, how's it going?
Good. How are you?
Doing pretty well. Just watching Criminal Minds.
Nice.
I'm kind of hooked.
Yeah, my fiance is really into those crime shows too.
I don't know why. Like, it's like spooky, but like I'm like obsessed with any true crime.
Mm.
I don't know. Like whenever I'm at work, I'm listening to true crime podcasts.
Yeah, she loves that true crime project
Oh,
podcast.
they're so good. I know there's one specifically called True Crime, but I haven't listened to it. I like the ones that have like really like immersive like background noises and sound effects and stuff like that. Um, I don't know about the and I guess also like the more ominous sounding narrators.
Really
I
add to
don't know
the.
if True Crime has that or not. I'd have to listen to it, but yeah, I don't know. I don't know why it's so interesting, but it is.
It's crazy because like a lot of those things, happen.
Well,
Heard.
yeah, that's the weird part. Is like it's all like real.
Yeah.
Like they're really grisly things, but it's interesting to listen to.
Yeah. Truth is stranger than fiction sometimes.
Yeah. There's one that I listened to a couple times called oh shoot, what's it called? No, I can't remember the name of it, and that's bugging me. But it's basically talking about the narrator's experience of researching and producing a true crime podcast, and like how it's affected him personally, like his personal life, and like how it affects like his ability to like to sleep a whole night.
Oh god.
There's some days where he just can't sleep because the things he researches are so dark.
Oh man.
Yeah, and then they also have occasional. Well, I guess those are like occasional like intermissions between the actual podcast, which is talking about true crime. But yeah, there's some pretty horrifying things in there.
Yeah, I used to watch Dateline with my parents sometimes, especially like when I would go visit with my parents, like a little bit when I was older in my life, and like the only thing I seemed to learn was never take out a life insurance policy on yourself, because that's just asking someone to frame to kill you and claim
Just like a
insurance.
magnet for hitmen.
Yeah.
Insomniac. That's the podcast I was thinking of. Oh, it's so good, but it's so dark. Actually, I'll put, if she's really into like true crime stuff, I'll put it in the Discord if you want to share it with her.
Okay. Yeah.
Let me find it on my computer. Where do I even put this? Memes?
Oh yeah, that works. Nice, got it. Thank you.
I gave it to one of my coworkers, and he got through like half of the first episode, and he was like, "I can't do this."
Yeah, actually, like those things kind of freak me out too. I usually don't like scary stuff just in general, or things that creep me out.
I used to hate it too, but I guess I still kind of do. Like I like being scared, but I also have like a love-hate relationship with like the anticipation. Like I like it, but I also hate it. I don't know. It's kind of weird, but
I could
yeah,
see
I used to
that.
hate that stuff, but now I love watching thrillers for that
That's
reason.
what. Yeah, that's what a lot of people tell me, that why they watch those things too. It's the anticipation.
It like gets your heart racing,
It
and it's
does.
kind of like an adrenaline rush when you get scared.
Yeah. Yes, if you don't have MATLAB, you can download it from the software tab. On my Fullerton. Okay, it's 5:30, so let's go ahead and get started today. All right, good evening, everyone. How's everyone doing today?
Good.
Good.
So far.
Yeah, yeah. It's the second week. It's still relatively calm, hopefully, but yeah, things will definitely get more busy. Okay, so so for today, the plan is to do some review. So we're going to be reviewing some MATLAB stuff. Yeah. How am I doing? Yeah, I'm doing good. Yeah, it was my mom's birthday this past weekend, so I went to visit her and I cooked dinner for her. Yeah. Lectures are recorded. Yes. Yeah. So this is being recorded right now, and then it'll be up on YouTube basically after the lecture. Yeah. So usually take a couple hours for I think after you record something on Zoom, Zoom has to convert it, and then I have to upload it on YouTube. Yeah. It's okay. Yeah, I can answer every time you ask it. Yeah. Okay. So today, we're going to be doing a MATLAB review. You guys might find it useful to follow along in MATLAB as well. So if you have MATLAB on your computer, go ahead and open it up. I'm going to be showing lots of code snippets, and we're going to do several examples today, just so that you can follow along. I'll be posting this script right here, and so this has basically all the examples that we're going to do today. I'll post this up on Canvas afterwards, so you can take a look. But if you kind of want to follow along in real time, then that's a good idea too. Okay. Okay. And so today, we're doing a MATLAB review, and today it's definitely much more of a crash course. So I know one day is definitely not, it's enough to cover at least the basics and the syntax, but programming is more of a it's not something that you kind of read in a book to learn. It's something that you kind of use a lot in practice. So today we'll be learning just kind of the basics on what you need, at least to kind of get started with the code we're going to work on in the class. But I expect, the MATLAB skills will be built upon, all throughout the entire class. So, as we learn more, more of the material and we write more scripts, and you're just gonna get better and better and better at it, as we go. But the goal for today is just to kind of get you up to kind of a starting point. So I'm hoping that a lot of this is review from your previous classes in 205. And I try to pack in as many examples as I could, just so that you can see some of the concepts in action. Okay. And so we're going to start with something with simple stuff, just simply, defining variables. Then we're going to go to some more, a little bit more advanced stuff that we're going to need specifically for this class. Number two is, something that I want you to know, pretty well, which is how to set up and solve a linear system of equations using MATLAB. Okay. And actually, the first time you solve a linear system in MATLAB, it's hard to go back because MATLAB kind of makes it as simple as possible. But we'll be using that, as much as we can. Okay. Oh yeah. So Juan brings up a good point too. So So most of this class, I'm going to be teaching it with the assumption that you're going to be using MATLAB. It's not a requirement. So if you want to use Python or you want to use another programming language, definitely feel free to do that. I've learned a lot of programming languages out there. So if you turn in code in Python, I'll have no problems understanding it and running it. But just keep in mind all the starter code and everything I'll be and all the support, most of the support I'll be given is in MATLAB. Okay, so any questions on any of this before we get started today? Okay, so let's go ahead and get started. Oh. Okay, and so kind of just before we start getting into MATLAB, I just want to talk a bit more about what I think about when I think computational engineering, and why do I choose MATLAB for this class. Okay, so computational engineering forms the backbone for a lot of what we're going to do in this class, and what it really refers to is how engineers can use computers and computer software to basically support their work. Okay, so I use the term augment here, but you can use support and stuff like that too, right? Notice I didn't say replace, right? Because I think in this day and age, everyone's kind of scared that robot overlords are going to take their job. But I think for engineering, we're usually the ones that design the robots. So when I say computational engineering, the computers are there basically just to support us. Okay. And so, the engineers, you're still going to have to be the one that proposes the problem, formulates the problem, interprets the analysis, and actually makes decisions. Okay. But computers can help us, perform a lot of the really tedious tasks of performing a lot of the computations. Okay. But in order to kind of leverage this, you have to set up your problems properly. Okay. And that means your code has to be good. It has to be understood by the computer, and it has to solve the right problems. Okay. And so this is what I mean when I say, when we have to code stuff. And so coding, all that really means is taking a problem that we as humans understand and putting it into a form that the computer can understand so that they can help us. That's all it really needs. Okay. And what you'll see is that computers speak a very specific language where they really want things in a very particular way in order for them to help you, right? So just like we talked about last week, so computers are both really, really powerful, but also really, really dumb at the same time. So you kind of have to hold their hand and present problems to them, in a good way. Okay. And so for performing engineering work, there's actually a lot of different programming languages that are available for engineers to use. Okay. And so MATLAB is the one that we're going to be using in this class. Python is another very popular one. I think is, it's getting more and more popular, every day. Okay. Python, the reason people use Python is that it's free. And so even if you're not a student, you can download Python and you can use it. And it has a very active community. So people are developing new packages and new code for Python all the time. And just kind of the culture of Python is that you kind of share it with the world. So it's nice. But the openness also leads to a lot of issues too. I was talking to my grad student last week that he's trying to use some obscure Python packages, but because Python is not handled by a company like MATLAB is, your random Joe that kind of develops his own Python packages is not going to test it, and it's not going to teach people how to use it in the same way that MATLAB does. Going down the line, we have C++. So C++, I think, among computer scientists is one of the most popular programming languages. Okay? We have Fortran. And so if you've heard of Fortran before, you're probably older than I am. But Fortran is a very ancient programming language that 99% of the people have moved on from. But it's the only reason the corpse of Fortran is still being kept alive, ironically, is because of people like me who write computational fluid dynamics software, actually. And so a lot of the old codes are written in Fortran, and for some reason in this community, no one wants to translate it. So that's why the corpse of Fortran still seems to be surviving, but no one else used it. And a new language that maybe you've heard of that's that I personally I feel like they're trying a little bit too hard to be trendy is called Julia. And so Julia actually has a lot of really nice things going for it, but I think it's still maybe 4, 5, 6 years from really catching on. But that's another one that's kind of up and coming. Okay. And for our class, what we use these codes for is to basically simulate problems that are governed by differential equations. Okay? Just like we saw last week with the the conservation equation that we were talking about. Okay, so why do we use Matlab? Okay, so Matlab is a program or programming language that is specifically designed for performing math. Okay, hence the term Matlab. Right, and what it really was designed for was ease of use. And so Matlab has a lot of built-in functions and a lot of nice syntax where it's easy to kind of pick up kind of as your first programming language and really just kind of get rolling with that. Is there a question? Oh, okay. And so it's used basically all throughout. So it's used a lot in education, as you guys have probably experienced. It's used in research. It's used in a lot of companies too. So I know sometimes if you go on forums online, people kind of poop on Matlab a lot, but it has its uses. I know a lot of like really professional places that use Matlab for everything that they do. Okay? So in terms of performance, Matlab is not going to set the world on fire. In fact, it's one of the slowest codes out there. And that's because they design it for more ease of use rather than performance. But it's still an excellent code for just quick prototyping and education, which is what we're going to be using it for. Okay. And this is kind of just more reasons behind that. So I think one other useful thing is that, relatively speaking, the error messages that Matlab gives you are pretty helpful compared to some of the other programming languages, but they can still be a little bit hard to decipher. Okay. And the other thing that makes Matlab a really strong choice is it has a very strong online community, and MathWorks, which is the company that manages Matlab, they're really good. So they do a really nice job of documenting their their code. So if you're confused about a certain function or something, you can look it up, and there's usually some pretty good documentation there. Okay. And believe it or not, Matlab is cheap. So I know everyone in this class gets it for free. But a commercial license for Matlab is only going to set you back about $100, which sounds like a lot. But if you compare that to some other engineering softwares out there, which can run up into the thousands or tens of thousands, Matlab is pretty cheap. So, if you go to if you end up working at a company, you can ask your boss for Matlab, and he's probably not going to blink twice. He's probably just going to buy it for you. Okay. But if you ask him to buy you like Ansys, which is several thousands of dollars, then that's kind of a different story. Okay, and so let's kind of get started with actually using Matlab. Okay, and so the first thing that we need to do is we need to know how to define variables. Okay, so any scientific program, any program that we write in Matlab, this is the first thing that we're going to do. So we're going to define some variables. Okay, and so the definition of a variable is a labeled entry that a computer program can use to basically store information where it can be later referenced or manipulated. Okay, and so if you think of like a variable that you use in some of your other classes, right? So you've used things like x, and they use that to represent some kind of number. Variables in code are exactly the same thing. So it's basically a way to say that for some reason we want to store this number 6 right here, right? And we want to store this number 6 for later use. And so the way that we can define it is we can give it a name, okay, and then we can assign it a number. Okay. And so variables, they can be used to store, here you see an example of storing just a scalar value, but it can also be used to store lots of different formats of data. Okay. And so a scalar is what you see down here, which is just a single value. But you can also have vectors, which is just an organized list of variables. Okay. Or you can even have a matrix. So you can have just basically one name refer to, an entire matrix of values. Okay. Okay. And so the two things that you need to do to define a variable are, one, its name. And so every variable has to have a name. Okay. You have to give it its value. So you have to tell the program what value that you want to store. And then the way you connect these two is with an equal sign. Okay. And so an equal sign is a very special character in programming, which basically means assignment. Okay. And so here's an example. Okay. And so basically our example in code reads scalar example equals 6, right? But the way you kind of read this in plain speak is that, is the way you say is, I have this variable, I'm going to call it scalar example. And then to the scalar example, I'm going to assign a value of 6 to it. Okay. And so, until we change it later, whenever we refer to scalar example later in the code, it's going to have a value of 6, okay? And just, one small thing is that, when you're writing code in MATLAB, this is actually optional, so you don't actually have to do this. But, it's usually good programming practice to end your lines of code with a semicolon, okay? Okay, so any questions so far on defining variables? Okay. Okay. And so now that we have this variable called scalar example, we can use it to store the number 6, okay? We can then use this variable later on in the code to perform some arithmetic calculations, okay? And so let's look at this another example here, okay? And so let's say we define a new variable, and so we call this number scalar operation, okay? But then now this variable here is going to be an operation that uses our previous variable, okay? And so what we're saying is that the value of scalar operation is going to be 3 times scalar example plus scalar example, okay? And so if we know from the previous page that scalar example has been assigned a number of 6, and so the way to read this line of code here is that this new variable scalar operation is going to be assigned a value of 3 times 6 plus 6. And so the new value of this variable will be 24, right? So we have 3 times 6, which is 18, plus 6, which is 24, okay? And so, this is kind of the big benefit to using variables, is so that we can kind of use them later on, right? And so, we can also use variables to define vectors too, right? And so let's say that, we want a single variable to have this list of numbers right here, 7, 1, 4, okay? And so we can use basically the exact same syntax. We can say that let's have this variable and let's call it vector example. Okay, so this is the variable's name right here. And then the value for this variable is going to be a list of 3 numbers, which is 7, 1, and 4. Okay, and so now this vector example here is a variable that represents a vector. Okay. And then, just like we did with scalars, we can perform operations with vectors as well. And so if we define a new variable here, vector operation, then that's going to be vector example, which is 7, 1, 4 right here. And then to that, we're going to add another vector right here, 4, 1, 7. Okay. And so this new vector, its value is going to be 7 plus 4. Okay. And so basically when you add vectors, you just add the entries on top of each other. Okay. So we have 7 plus 4. And so the first entry of vector operation will be 11. Okay. And then for the second entry, we have 1 plus 1. And so 1 plus 1 is 2. And so 2 is going to be in the second slot. And then in the third slot, we're going to have 7 plus 4, which is going to be 11. Okay. And so this new vector right here, vector operation, will be 11, 11. 11, 1, 11. Okay. Any questions on this so far? Okay, so let's kind of see this in action. So let me go to my code. Oh, sorry. Sorry, this the chat seems to be, I don't know what it is with this lecture, but the chat seems to not notify me when there's stuff in the chat. Let's see. Have I experimented with any neural networks? So no, I haven't actually. So neural networks is basically something that's used for machine learning. So I have one graduate student that's working on it, but I personally have not used it. I thought the MAT was referring to matrices, not math in general. I think it's yeah, actually you're probably right. I think the mat refers to that, not just math. Yeah. Mm-hmm. Oh yeah, it's 11, 2, 11. Yeah, thank you. Mm-hmm. Yeah, that's what I get for trying to do numbers in my head. Okay, and so here's basically the code that we've written so far. Right? MATLAB toolboxes for machine learning stuff is pretty fun. Yeah, I'll have to try it out sometime because one of my grad students is really into that too. Okay, so here's the MATLAB code that we have so far, right? And so we have, we define scalar example to have a value of 6. Okay. Then we did scalar operation, so this should be 24. And then this is our vector operation here, which is going to be 11, 2, 11. Okay. And so we can go ahead and run this code. Okay. And so it's plotting something right now because that's going to be showing up later. And then let's check out some of these values. This Matlab plot is like just beyond this. Okay. And so first let's check out scalar operation. So this should be 24, right? And so that's a value of 24, just like we said. Okay. And then we have vector operation, which just have a value of 11, 2, 11. And it does right there. Okay. So perfect. Okay. No, we're not going to do machine learning in this class. That's I need to learn enough about it myself in order to actually teach it, but we're not going to use it. Okay. Okay. So let me do this. Okay. And so let me do the rest of the lecture kind of like this, so you can kind of see it kind of side by side. Okay. Let's see. Okay, and so the next thing that we're going to talk about are special functions for defining vectors. Okay, and so we've gone over kind of the most basic way to define a vector here, which is where we define each of the entries kind of one by one. And so this is fine, and so you can definitely use this. But for our class, there's other functions that we can use to actually define vectors that are going to be useful for us. Okay. And so one specific example of this is called the Linspace vector, or Linspace function. Okay, have you guys used Linspace before in your previous classes? Okay, you've used it before. Great, awesome. Yeah, Linspace is a great function. Right? And so Linspace, yes. So there's equivalent ones in Python too. Right. So what Linspace is going to do is it's going to create a vector of a list of values for you with a specified starting point, a specified ending point, and then a specified number of entries in that vector. Okay. And so if we look at this example here, and so I'm saying, Linspace example is going to be Linspace 0, 10, 5. Okay. And so what this is going to do, it's going to create a vector. Okay. The first value in this vector is going to be 0. The last value in this vector is going to be 10. Okay, so that sets our first and last point. And then this last number right here, this is going to specify how many entries that we want in that vector. Okay, and so since we specified 5, there's going to be 5 entries in this vector. Okay, and so you can see the result here on the slide. So this Linspace example, we see the first entry is 0, the last one is 10. Okay, and then all the other entries are evenly spaced so that you have 5 entries overall. Okay. And so to get 5 entries, you're going to have 4. You can basically divide by 4, which is number of entries minus 1, and then that will give you the spacing. Okay, so we're going to go 0, 2.5, 5, 7.5, and then 10. Okay, and so that's how you use Linspace. So for an example like this with only 5, maybe it's not that we can easily kind of code this manually. But say that you want to create a Linspace with 50 points, right? So let's change this to 50, okay? And we can run our code. And then we come here and we check the Linspace example. And you can see here, we have our vector is now 50 entries, okay? And then between each entry, looks like it's 0.2041, okay? And so now this created a vector where the starting and ending points are defined, and then all the other entries are kind of equally spaced, okay? Just what's nice. Let's make it 51. There we go. Okay. And so with 51 entries, we have, the spacing is 0.2. Okay. And so Linspace is really nice, where if you have to kind of make a continuous, list of numbers, then Linspace is kind of a shortcut for you to do that. Okay. Another function that we'll use a lot in this class is the zeros function. Okay. Have you guys used zeros before in your previous classes? Great, awesome. This is good. Yeah. So if you haven't seen the zeros function before, the zeros function will create an empty vector for you. Okay. And what empty basically means that every entry in that vector is going to be 0. Okay. And so, you know, for this example right here, we have zeros example is equal to zeros, 100, 1. Okay. And so what this will do is it'll create a vector for you with 100 entries. Okay. This one right here specifies the fact that, you know, we only want one column. Okay. And so this is going to be a matrix with 100 rows and one column, and then everything is going to be 0. Okay? And so if we check kind of the MATLAB, response for this, we have zeros example. Okay. And you can see here we have 100 entries and they're all 0. Okay. And so we're going to use this a lot in this class because a lot of times we want to create kind of an empty matrix and then fill them in later. Okay. And so definitely get used to using the zeros command. Okay. Any questions on this so far? Okay. Okay, so let's talk about manipulating variables. Okay? And so once a variable is defined, its value is not set. So you can actually manipulate it as much as you want. Okay. And so let's say that, you know, earlier when we set this, the value of this to be 6, let's say that later on in the code, you know, we need this value to be 9. Okay. And so, you know, all it takes to redefine a variable or to manipulate its value is just to use the same syntax as before. So we're going to use, we're going to call its name again. And so we're going to say scalar example. And then we're going to use the equal sign. And so the equal sign means assignment. And then we're just going to give it a new value. Okay. And so we can say scalar example equal 9. Okay. And that assigns a value of 9 to scalar example now. And so it kind of forgets that that its value used to be 6. And then from this point forward, the value is going to be 9. Okay. And so the ordering is key. Okay. And so just because we redefine the value of 9 here, the code doesn't know that until it actually reaches this point right here. Okay. And so if you kind of read these 3 lines right here, so line 6, line 8, and line 14. Okay. Some people, you might be inclined to think that, the scalar operation would be 3 times 9 plus 9, right? Because later on in the code, we redefine, scalar example to be 9. But, when you call this line of code right here, scalar example its value hasn't changed yet, okay? And so when you call this line of code, scalar example has a value of 6, okay? It's not until line 14 that scalar example, changed its value to 9, okay? And so that's an important thing to note is that, when you're reading your MATLAB scripts and you're evaluating them, they kind of go from top to bottom. And so if you change the value of a variable later on, it's not going to actually take on that variable until the code actually reaches that, until the, MATLAB actually reaches that line in the code. Okay. And so, we can also use variables in mathematical operations. Okay. And so, here's an example of, we assigned a value of a new variable to be 7. Okay. And so we say this variable called new variable is 7. Okay. And then we can, but then we can redefine this value of new variable to be the combination of some other ones. Okay. And so let's say that we define this new variable called whodis. Okay. And so what we can say is that new variable is equal to whodis plus 5/2 times whodis. Okay. And so at the end of this line right here, actually new variable still has a value of 7, okay? Because it's going to be 2 plus 5/2 times 2, which is 7, okay? And so here we redefine its value, okay? Okay. We can also update the value of a variable. So this is actually really important right here because we're going to use this quite a bit, okay? And so I use this notation a lot where, we want to say that we want to, keep the old value of a variable, but then use it in a new operation and then simultaneously assign that value back to the same variable, okay? So it's a little bit of a mouthful. So let's kind of walk through this example right here, okay? And so let's say that, whatever value is in whodis, so right now whodis has a value of 2, right? And so let's say that we want to add 9 to this variable, okay? And so the way that you do that is you say that, whodis is equal to whodis plus 9, okay? It might seem a little bit, unintuitive to use the name of the variable on both sides, but here's kind of how you read this, okay? And so the way you kind of read this, when you're using update notation is you say that the new value for whodis is, okay? So that equal sign means is, okay? And then when whodis appears on the right-hand side of the equation, this refers to its old value. Okay? So its value hasn't updated yet. So the old value for whodis is still 2 right here. Okay. And then to this, we're going to add 9. Okay. And so what we're saying is the new value of whodis is equal to 2 plus 9. And so now it's going to be 11. Okay. And so we're going to use this a lot in this class because it's just kind of, naturally how, a lot of these methods tend to be. And so it's really important to kind of understand what I call this update notation. Okay. Okay. Any questions on this? Oh, questions? Let's see. Yes, yes. So Juan brought up a good point. So in C++, C and C++, this is a very common thing to do. And I think, I'm not sure if they call it overloading the variable. They might have a different definition, but this is very common syntax in C++ as well. Yeah. Oh, I see. Yeah, it can be a little bit confusing, but we're going to use that a lot in this class because the way that we're going to use it is we're going to basically create an empty matrix, and then we're going to be updating each of the values in the matrix in a loop. And then what's going to happen is that the loop is probably going to visit some overlapping entries, and so we're going to need to add to it instead of just completely overwriting. Yeah. Yeah. So we're gonna use this font. Yeah, just some trivia. It's actually, this syntax right here is actually used in the standard syntax for a C++ for loop. Yeah, I see. You can do that in some cases, but in this case, what you'll see in a lot of our methods, we're going to create kind of a big matrix, and then what we're going to do is we're going to be continually updating that matrix as we go throughout the code. So it's important to kind of just keep one matrix. And then just kind of continually updating its variables. So we'll be using this syntax for it quite a bit. Yeah. Okay. All right. So let's go ahead and move on. Okay. All right. So let's talk about using variables. So variables can be used in a lot of different ways in a program. Some might say that it's kind of the basis for a lot of computer programming. Okay. Oh, question? Okay. And so, one way that you can use variables that we're going to see is to what I call permanently store important problem parameters. Okay. And so what I mean by this is that oftentimes when we're running, these scientific programs, there's some values and some variables where, we're going to define them at the very beginning of the program, and then their values are just never going to change. So we're basically going to refer to them, later on. Okay. And so one very simple example of this is, let's say that, we have a circle, and it has a radius of 4, okay? And that circle kind of represents something in reality. So let's say, it's the radius of the bottom of my cup right here. So let's say that is 4 centimeters something. Okay? And so it's a variable that we're not really going to change. It's just something that, it's just to help us remember that the radius of our circle is 4, okay? And so, variables like this, I like to call them, parameter variables, okay? Because they just are used to define parameters. And so later on in the code, this radius might be used to something like computing the area. Okay, so you might say area is equal to pi times radius. Okay. And so just to kind of give you a preview, and so this is the project from last year. Okay, and you can see what this person did was at the very beginning of their code, they listed out all these important parameters here at the beginning, and these parameter values never change. Okay. And so, that's kind of a technique that we're going to use in this class quite a bit too. Because the nice thing about this is that you can kind of just look at the top of the program and you can kind of see a lot of the important variables there. Okay. Oops. Okay. And so another important use for variables is for what I call temporarily storing values. Okay. And so a lot of times, we'll be using variables just as kind of, temporary things so that we can compute something, store it, and then, kind of store it just for kind of temporary use. And so these kinds of variables are constantly being changed and constantly being updated, according to the algorithm. Okay. And so, it's perfectly okay to use variables like that. And so it might be a little bit confusing, especially when, variables are changing their values quite a bit. But it's kind of useful just for compactness and kind of just for sanity. So you're not creating a ton of new variables too. Okay. All right. And this last point that I want to make on this slide is extremely important. And so, when you're creating variables in your code, you want to make sure that you use really distinct and descriptive names for your variables. Okay. Because the worst thing in the world is when you're debugging and you're looking online, maybe like line 151 or something, right? And you see a variable called v, okay? And you're like, v, where the hell did you come from? Like, what do you mean, right? And so just from v, like you have no idea what the heck that could mean, right? But if you call it something, more descriptive like velocity, right? Then you know that this v represents velocity, and trust me, it makes your debugging lots and lots easier, okay? And so use very descriptive names for your variables. So don't, try not to use them single letters like X or Y, and try not to curse too much on your code too. So, and so I'll say that I'm guilty of this a lot. So, a lot of times when I'm really frustrated with my code, I use profanity in my code too, and sometimes that makes it work better. But try to limit it too much. Okay. That's my code actually. So that was my solution for the project. But your guys' project's gonna be different. So don't bother going and playing this YouTube video on 25% speed. Yeah. Okay. Any questions on this so far? Okay. Okay, so that's everything with scalar and vector variables. Let's talk about matrices a little bit, because matrices are going to be really important. Okay, so matrices are going to be really important for us because they help us perform linear algebra. Okay, so just like we talked about last week, computers are really good at linear algebra, and so in order to formulate problems as linear algebra problems, we need to use matrices quite a bit. Okay. And so we're going to be seeing matrices a lot. Okay. And so, there's several different ways that you can define matrices in Matlab. Okay. The first way that we're going to talk about is just the simple manual method. Okay. And here you basically list out every entry in the matrix, kind of entry by entry. Okay. And so in this example here, I have a 3x3 matrix. And so the first row is going to be 1, 1, 1. The second row is going to be 9, 9, 9. And then the last row is going to be 4, 6, and 8. Okay. And so let's break down this line of code a little bit. Okay. And so the way to read this is that, notice how I use both commas and semicolons. Okay. Well, I guess first of all, notice that I've kind of enclosed this entire thing with square brackets. And so I know that there's different ways to define matrices, but I like to use the square brackets just because it's to me it's kind of a unique identifier for matrices. But if you have different ways, then that's fine with me. Okay. But in this method, we're basically defining the matrix kind of row by row. Okay. And so going from left to right, we're going to define the first row, and then we're going to separate entries in the first row, or entries in the same row are separated by commas. Okay. And so since this first row is just going to be all ones with 3 entries, so we have a 1, 1, 1. Okay. And so the fact that we use commas here tells MATLAB that all these guys belong on the same row. Okay. And then when we're ready to move on to the next row, what we use is a semicolon. Okay. And so this semicolon basically tells MATLAB said, okay, I'm ready to go to the next row now. Okay. And then for the next row, since all these guys are going to be in the same row again, we're going to use commas. We have 9, 9, 9. Okay. And then to go to the last row, once again, we're going to use a semicolon. And then we're going to write out the last row, which is 4, 6, 8. Okay. So that's one way to define a matrix. And so this is nice where, if you know exactly what values your matrix is going to have, this is kind of a very compact way to define it. So it just takes up one line, you define it and then you're kind of done with it. Okay. This is not the common way that we're going to define matrices in this class. Okay. And so actually the way that we're going to define matrices most commonly is we're going to use that zeros command that we talked about earlier. Okay. And so remember the zeros command, what it does is it creates kind of an empty data container. And so in this case, it's going to create a 3 by 3 matrix. And every entry in that matrix is going to be 0. Okay. And then what we're going to do is we're going to manually assign each of the entries in that matrix with a value. Okay. And so to kind of produce the exact same matrix that we did before, we can create a empty matrix of 3, 3, okay, and then go to and visit each of the entries and assign their values, okay. And so this line of code says that the 1, 1 entry, so the entry in the first row and the first column is going to be 1, okay. Then the next line of code says the entry in the first row and the second column, that's going to be 1, okay. And then the entry in the first row and the third column is going to be 1, okay. And so these 3 lines basically mimic this over here, okay. And then you can continue that on, for all the rest of the entries. Okay? And so, you might be asking me, why would we ever do this, which takes, 10 lines of code when we can do the exact same thing in 1 line of code, right? That makes no sense. It seems like, I'm just making you type stuff just, because I'm sadistic or something like that. And so the reason we do this is that, when we start to developing some code for this class, what you'll see is that we're going to have gigantic matrices. So they might be like hundreds by hundreds, okay? And the way that we build this matrix is with a for loop, okay? And so for loop, what that's going to do is it's going to visit every single row in the matrix. And then from there, we can define that, we can assign values to that row, okay? And it's, you'll see it's actually a lot more convenient to start with kind of an empty matrix and kind of assign it, entries like that, okay? Another reason for this is that, just kind of naturally, based on the methods that we're going to use in this class, the vast majority of the entries in our matrices are actually going to be 0, okay? And so, just by an example, like you have a matrix that's 100 by 100, okay? And so, the total amount of entries in that matrix might be whatever 100 times 100 is. So that's 10,000, okay? And so out of those 10,000 entries, maybe only like 200 of those will be non-zero, okay? The rest of the 9,800 of those will be 0, okay? And so it makes a lot of sense that, if 99% of our entries are going to be 0, let's just define all of them to be 0 first, and then whatever entries are not 0, then we can go ahead and fill those in manually, okay? And so I know right now it just seems like a pain to type, this over and over and over again, but this is the way that I want you guys to get used to defining matrices, because it's going to help us out, later in the class, okay? Okay, so any questions on this so far? Right. Let's see. Is it okay to use single if we? Yeah, I mean, I'm not forcing you to use single letter. I'm not forcing you to not use single letter variables, but I'm saying is that when you're writing kind of bigger codes, single letter variables kind of tend to be more difficult to debug because it's it's a bit harder to remember what they are. Yeah, but I'm not going to mark you down if you use single letter variables if you know what they mean. Yeah. Yes. Right. Mm-hmm. Yes. Yeah. So yeah, copy and paste will be your friend for this for now. But we'll do some examples later on in the class where you'll see how we can build up a matrix with a loop. And so in those cases, you don't have to do so much Control C, Control V. Yeah. Mm-hmm. Okay. Okay, and so we can also manipulate entries in the matrix. So a lot of the same logic that we used kind of before for the kind of the update notation we can use here as well, okay? And so this is something you'll see quite a bit in the class where like say that, we want to update only this entry in the matrix right here. So just the 1, 1, okay? We don't want to forget what it was before. In fact, we only want to add to it, okay? And so the way that we do that is the same way we did before. So we say that the new value of the 1, 1 entry in this matrix is going to be equal to or assigned the old value in that matrix. And so the old value in this spot right here is 1, okay, plus 47, okay? And so after the evaluation of this line right here, then the 1, 1 entry for this matrix is going to be 48, okay, because it was 1, which was there before, and then plus 47, which is the new one. Okay. Okay. And so now we're getting on to linear systems. Okay. And so just like we said, the most useful thing that MATLAB can do, at least for us, is solving linear systems. Okay. And so the way that we do this is we have to put it in matrix form. Okay. And so what we're going to do is that we're going to have a set of linear equations. So let's say that we have these 3 equations and 3 unknowns. And so we have 3x1 plus 5x2 plus 7x3 is equal to 0. And then we have another equation, x1 plus 9x3 is equal to 3. And then x2 minus 3x1 is equal to 6. Okay. What we need to do is we need to put this in matrix form. And so what that means is that we're extracting the coefficients here in front of each of the entries. Okay. And so that we form a matrix system like this. Okay. And then from here, what we need to do is we need to define a matrix that represents this. And so I call this the left-hand side matrix, or the LHS. Okay. And then we need to define a right-hand side vector, or the RHS, right here. Okay. And then we're going to use a magic MATLAB operation here called backslash. Okay. And so what backslash does is that it will solve your linear system for you. Okay. And so if you define the matrix, the left-hand side matrix, and you define the right-hand side vector, then you use this backslash notation, then that will solve your linear system for you. And so this X solution right here will have the values of x1, x2, and x3 for our linear system. Okay. Any question? Yes. Yeah. So two brought up a good point too. So we can also use colon notation. So if we want to set an entire row equal to 1, then we can say that zeros matrix 1 comma colon is equal to 1, and that sets all the entire row equal to 1. Yeah. Yeah. So that's a great point too. So we'll be using that a little bit in this class as well. Mm-hmm. And so colon notation is basically a way to kind of grab an entire line. Yeah. So basically what 2 is saying is that instead of doing this, and so let me comment this out. Oh, if you don't know how to comment groups of lines, you can highlight a bunch of lines in MATLAB and do Control R, and then Control R will automatically comment those lines. And if you want to uncomment a group of lines, you can do Control T, and that'll uncomment them. Okay. And so let me comment those lines. Okay. And so what 2 is saying that is we can do this. And so let's say that we want to set the entire first row equal to 1. Okay. And so if we're setting the entire first row, then we need to specify 1 right here. Okay. Then we can use a colon, and then we can just set a 1, just like that. Okay. And so this will set the entire first row equal to 1. Yeah. Right. Yes. Yeah. So there's another question in the chat. So what if you want to do that on the diagonal? You can use the identity matrix command for that as well. Yeah. But in terms of a shortcut on how to do it with colons, I think there might be a way to do that, but I'm not sure what that is. But yeah, the way that I would do is I would start with an identity matrix, set a value on that identity, or just multiply by that, and then just assign the rest of the values from there. Yeah. Or you can do it with the loop, which is kind of what I commonly most do too. Okay. And so when we run this code and we check this X solution right here, this has the values of x1, x2, and x3. Okay. And so the solution to this linear system right here, which I think I have on the next page. No, we don't. And so the solutions for this linear system is going to be minus 1.8774. That's the value for x1. x2 has a value of 0.3677. And then x3 has a value of 0.5419. Okay. And so, we're going to be using this a lot in this class. So we're going to be setting up a lot of linear systems, and then we're going to be using the backslash in MATLAB to solve them. Okay. And so this is magical right here. So, and so it looks like a very simple line, but underneath the hood, it's actually doing a lot of really cool work. So MATLAB is kind of smartly choosing kind of a really good method to solve your linear system. So it's actually pretty cool. Okay, so any questions on solving linear systems in MATLAB? Can you see my solution? Yep. For the linear system. You good? Nice, great. Okay. Okay. And so that's kind of, basic matrices and solving linear systems. Now let's start to get into a little bit more advanced stuff, okay? And so let's start with some conditional programming, okay? And so when I say conditional programming, what I mean is that, sometimes we want our program to do something different, depending on the situation, okay? And sometimes we don't know what that situation is going to be until we actually run the program, okay? So I remember I was talking to, one of my friends before. He said, if you're not sure, or, what's the point of writing an if statement if you're writing the program, you know what's going to happen, right? And so, sometimes you don't know, because sometimes you're writing the program and it's computing things where, you're not sure what its value is going to be until you actually run the program. Okay. Nice. Yeah, so in the chat right now, so Juan has the solution of if you wanted to solve that in Matlab, or in Python, sorry. Okay, and so the syntax for for doing conditional programming, or at least the most basic one, is an if statement. Okay, and so here's kind of the general format here. So we start with an if. Okay, it's a key word because when you type it, it turns blue, which is always nice. Okay. And then in the parentheses here, we have what I call the check condition, okay? And so this is a statement that can either be true or false, okay? And then if the condition is true, then what we do is we enter the body of the if statement. And so here we just have one line in the if statement. And so it's the function called perform work if true, okay? But if it's false, then it kind of just skips over this entire thing, okay? And so, if this check condition is false, then we just kind of just ignore it, okay? Okay, and so here's a couple examples. So here I have kind of the latest one here, okay? And so let's say that we have this snippet of code right here. And so let's say that we have a variable called needs correction, and it has a value of 3, okay? Then we enter this if statement. So we say if needs correction is less than 5, then we assign a value of 5 to needs correction, okay? And so in this line of code, we first check this condition here. And, since in this first version right here, we have 3. And so since 3 is less than 5, this condition will be true. And in that case, we enter the body of the if statement, and then we assign a new value of needs correction, okay? And so the result of running this batch of code right here is that needs correction has a value of 5, okay? We compare that to this code on the right, okay, which is what I have here on the sample code. Whereas, if we have needs corrections equal to 9, then it doesn't need correction, right? So we check this condition in the if statement, and we say if 9 is less than 5, and so obviously that's false, right? Unless you're living in a world of wacky math, okay? And so since this is false, then we just ignore everything that's in the if statement, and then needs correction kind of retains its original value. So the result of this code is that needs correction will be 9, okay? And we can check our workspace here in Matlab just to confirm, okay? Oh, I use it again later on. But after this line of code right here, then needs correction will be 9, okay? And so that's kind of just the basics of an if statement. So in order to get an if statement, you need a check condition, which is something that can be either true or false. And then, depending on if that's true or false, then you're going to enter the if statement and execute some code. Okay. But if it's false, then you're just going to ignore it. Okay. All right. Any questions on this? Okay. All right. So let's get into Elsif. Okay. So sometimes, an if statement is nice if you have only just one condition. But what if you have more than one condition that you want to check, okay? And so let's say that we have a case where, we have the first condition that we want to check, but, in case that first one fails, then we have another condition that we want to check, okay? And so that's where the Elsif comes in, okay? And so, the way to kind of read this is that if this is true, but if this is not true, else if this is true, then execute this line of code in here, okay? And so in order to do an else if statement, you need 2 conditions. So you need one condition first, okay? And then if that condition succeeds, then we're going to do just the body of the first if statement, and we're going to ignore everything else, right? But if condition 1 fails, then we're going to check to see if condition 2 is satisfied. And if condition 2 is satisfied, then we do, the body of that else if statement, okay? And so it's kind of like an either or thing, or either or neither kind of thing, okay? And so, whenever you have an else if, first you're going to check the if condition. And if that's false, then you're going to check the else if condition, okay? And if that's false, then you do nothing, okay? And so here I have kind of 3 examples right here, okay? And so let's say that, we have one case where we have this variable needs correction is equal to 11, okay? First, we check if needs correction is less than 1, okay? And so that's obviously false since 11 is not less than 1, okay? Then we check the next condition here. And so we check if needs correction is greater than 7, right? And so since that is true, then we enter this body of the else if statement. And so we assign a value of 7 to needs correction, okay? Okay, and so now let's do another example here where the first condition is going to be true, and then we're going to ignore everything else, okay? And so let's say that instead we start with the value of 0, okay? Then we check to see if needs correction is less than 1. And so since that is true, we're going to go into this line right here and assign a value of 1 to needs correction. And then we're just going to ignore everything else. So since the first condition was true, then we don't need to check the else if, because the first one already returned true, okay? Okay, and so in this last example here, none of those conditions are going to return true, and so we don't do anything in there, okay? And so let's say that we have needs correction is equal to 3. First, we check if 3 is less than 1. Obviously, that's false, so we can ignore that. And then we check if 3 is greater than 7. And so that's false, and so we could ignore that. And so, in this case, we don't do anything in this if statement. And so we just use a value of 3, okay? Okay, any questions on else if? Question, okay. Why can't you just make a switch case? You can definitely do that. So if you have a lot of different cases, you can do a switch as well. Yeah, so a switch is kind of a statement that's used for if you have kind of a lot of different cases. Yeah. And yeah, you can keep using else if you have more than 2 scenarios. Yeah. Right. So so we're going to go over else statements right after this, but you don't have to have an else. And so for an if statement, actually, the only thing you need to have is just the first if. This else if is optional, and the else is also optional. Yeah. And then the end, the end ends for that if statement. Yeah. So end is a special keyword in MATLAB. It's used to both end a for loop, and it's also used to end an if statement as well. Yeah. Mm-hmm. Okay, so let's go over else statements. Okay. And so else statements, they're another kind of a addition that you can provide for if statements. Okay, and so an else statement is something that you can is something to tell the code, say, if all else fails. So if all the other conditions up to this point failed, then do this. Okay, and so this is something that that's basically guaranteed. So you're basically guaranteed to do something in this if statement, at some point. Okay. And so the way to read this is that, first you check if condition 1 is satisfied. And then if condition 1 is satisfied, then you do this work, okay? But if condition 1 is false, then you check condition 2. And if condition 2 is true, then you do that work, okay? But if both condition 1 and condition 2 are false, then you enter the else loop, okay? And then else, then you do work, I guess, okay? And so the thing with the else statement is that, no matter what happens in this if statement, you're going to do something, okay? But, remember, whenever you use, else if and else, you're only going to do one of these blocks, okay? And so you're never going to execute 2 of these at the same time. And so you're only going to do one of these statements, okay? And so if condition 1 is satisfied, then you do this work and you ignore everything else. If condition 2 is satisfied and condition 1 is false, then you do that work and you don't do anything else. But if condition 1 and 2 are false, then you just do work, I guess. Okay. Okay. And so one example for this is say that we have needs corrections equal to 3. Then we check the first condition. So we check if 3 is less than 1. And so since this is false, we're going to ignore this. Then we check to see if 3 is greater than 7. And so that's false, so we can ignore that. And so since both of these conditions resulted in false, then we do the else condition, which is 4. Okay. And so this is kind of an example of the else statement coming into play, where you just you just do kind of the very last statement in the if statement. Okay. Yes. Yeah. So Juan brings up a good point. So whenever you write if statements, you have to use the end. And so you have to end every if statement with end, because that's basically MATLAB's way of knowing where the end of this if statement is. Okay. And so you have to make sure you always kind of add that to the end of your if statements. Okay. Okay. So any questions on else statements? Okay, and so that's if statements. Okay, and so there's a lot more you can say about if statements, because they get pretty complex, but this is kind of just the basics of it. I think everything else that you'll learn for if statements kind of gets thrown from practice. Okay, and we'll do a lot of examples. So probably we don't have time for the examples today, but we'll pick that up next time. Okay, but we do have 15 more minutes, so I do want to get through for loops. Okay. And so for loops are a way to do what I call repetitive programming. Okay. And so a lot of times in programming, you want to repeat a set of programming statements, many, many times. Okay. And so one way that you can do it is you can simply Control-C, Control-V and do that 100 times if you want. Okay. But another way to do that in a much more compact way is to use for loops. Okay. And it's actually, really nice, because in for loops, we actually gain access to what's called an index variable, which is, really useful. Okay. And so the anatomy for a for loop kind of looks like this. Okay. And so you start with the keyword for. Okay. And so you can see it's highlighted in blue. And so that tells you it's a key word. Okay. Next, you give a name for the index variable. And so this is a variable that's going to be counting up as you go through the for loop. Okay. Then you give a starting value for the index. Okay. And that's given by the 1 right here. Okay. And then you put a colon. And then after the colon, you put the last value to visit, which is the 5. Okay. And so the way to read this is that, for index is equal to 1 through 5. Okay. And so what this says is that this loop is going to loop 5 times. And then index is going to go between 1 and 5, and it's going to count up by 1 each time. Okay. And so on the first iteration of this loop, index is going to be equal to 1. On the second iteration, index is going to be equal to 2, and then 3, and then 4, and then 5. Okay. And so this is useful. So actually, this is actually better than having to copy and paste this line, 5 times, because we can actually use this index within the body of the loop. Okay. And so let's look at this line of code right here. And so in this line of code, we're saying that loop vector at index is equal to 2 times index. Okay. And so this is useful because what we're doing is we're assigning basically every entry in this loop vector variable right here. Okay. And we're doing it kind of very elegantly within the loop. Okay. Because remember, because this index is counting up, this is a great way to what I call visit every entry in this vector. Okay. So on the first iteration of this loop, then we're going to visit the first entry of the vector. On the second iteration, we're going to visit the second entry, then the third one, then the fourth one, and then the fifth one. Okay. And then each time we visit, we're going to assign a value to it. Okay. And so the value that we're going to assign to each value or to each entry in the vector is 2 times whatever its index is. Okay. So let's kind of walk through this iteration of the loop. Okay. Okay. And so we know that, because we're looping from 1 to 5, that this for loop is going to iterate 5 different times. Okay. And so when we start out, before we enter the loop, this loop vector is a zeros. And so that means it's going to have, 5 entries. So 1 row and 5 columns. and each of them are going to be 0. Okay. And then as we go through this loop, then we're actually going to assign values to that vector. Okay. So let's look at the first iteration. So in the first iteration, index's value is 1 because that's where we're starting at. Okay. And so what we're saying is that loop vector at 1 is equal to 2 times 1. And so the way to read that is like this. Okay. Okay, we're going to have loop vector at 1 is equal to 2 times 1. Okay, because that's the value of index on that first iteration. Okay, and so the result of that is that the first entry in this loop vector is going to be 2, right? And so all the other entries we haven't assigned them yet, so they're all going to be 0. Okay. Okay, and so let's move on to the next iteration of the loop. And so on the next iteration of the loop, index is going to be incremented by 1. And so now it's going to have a value of 2, right? And so we're going to do loop vector at 2 is equal to 2 times 2, which is 4, right? And so the way that we can show this is that the second entry in loop vector, which is given by this guy right here, okay, is going to be equal to 4. And so we have 2, 4, 2, 4, 0, 0, 0, okay? And then we can kind of continue on with this. So once the index's value is 3, then we assign the third entry, okay? And then we're going to assign that to 6. Then on the fourth iteration, that index is going to be 4, okay? And so then our vector looks like that, okay? Then once index reaches 5, then we know that this is going to be the very last iteration of this loop, okay? And so after this, the loop is going to be done. So at the 5th entry, we say that loop vector at 5 is going to be equal to 2 times 5, okay? Because remember, index's value is 5 on that last loop, okay? And that's how we got this 10 right here at the end, right here, okay? And so this is one of the most common ways that we're going to use loops in this class. So we're going to use loops to basically visit entries in a vector, or more commonly in a matrix, and then we're going to assign values to that, based on the index, okay? Okay, any questions on this? I'll leave this here. Oh, questions? Yes, okay. Right, so there's a question of why don't I add a semicolon after this first line? Yeah, that's a good question. Because for most other lines in MATLAB, we add a semicolon, but we don't add it for the if statement either. And so because this line for the ifs and the for loops, they're kind of special lines. They're not really, they're kind of more operating lines. That's what I like to think of them. We don't end them with semicolon because they're used for operation. And so since in this first line we're just defining the for is equal to something, then we don't need a semicolon. So it's same thing with end. And so usually kind of a good rule of thumb is that if you're in MATLAB and your line starts with kind of a special word right here that's highlighted in blue, most of the times you don't need a semicolon at the end of that line because it's MATLAB kind of recognizes it as a special line. Yeah. Yeah. Yeah, so a lot of good explanations for the semicolon in MATLAB. Mm-hmm. Okay, so that's the basics of for loops, right? And so now let's go over nested for loops, okay? And so we're going to do a little bit of exhibit here. So like say exhibit came to your house and said, we heard you like for loops, so we put for loops in your for loops, okay? And so you can put for loops inside for loops, and that's going to be even more madness, okay? And so kind of the term for this is, a nested for loop, okay? And so let's say that, we have something look like this. We have for, row index is equal to 1 to 3. And then, and then inside that for loop is going to be another for loop, which moves from 1 to 5, okay? And so the most common kind of application for this is to visit, entries in a matrix, okay? And so basically we can have one for loop that loops over all the rows, and then we'll have another for loop that loops over the columns, and that'll allow us to kind of visit every single entry in that matrix, okay? And so this can kind of be a little bit confusing to people for the first time that you're seeing this. But the way to kind of think of this is kind of like an outer loop and an inner loop. Okay. And so basically, this outer loop, we know it's going to iterate 3 different times. And then each time this outer loop iterates, then this inner for loop is going to complete. Okay. And so if we kind of work through the logic for this, we're going to say that for row index is equal to 1. So we're going to start at 1. Okay. And then when row index is equal to 1, then the inner loop is going to cycle 5 times. Okay. Then once the inner loop is done cycling 5 times, then we go back to the outer loop. And so the outer loop is going to be 2. And then from there, the inner loop is going to iterate another 5 times. And then from there, row index is going to be 3. And then once row index is 3, the inner loop is going to go another 5 times. Okay. And so the total amount of times that the inner loop iterates is actually going to be 15 because it's, 1 to 5. But then it does this entire sequence 3 different times because the outer loop is that. Okay. And so the analogy that I like to think about is actually, an analog clock, right? And so the outer loop in an analog clock is kind of like the hour hand, and the inner loop is kind of like the minutes hand. Okay. And so basically every time the hour hand moves, so let's say it moves from 12 to 1, the minutes hand has to make a full rotation, right? So it has to go all around the clock, and then the hours hand switches over. Okay. Same thing for the next hour, right? And so it's kind of like the same thing here, right? And so every time that the outer loop iterates, the inner loop has to kind of finish its full cycle. Okay. Okay. And so let's look at kind of an example of this in action. Okay. And so let's say that we have a matrix. Okay. And so let's say I create an empty matrix, which is going to be 3 by 5. And then let's go ahead and build up this matrix using a nested for loop. Okay. Okay. And so here I have kind of 2 for loops, and I have what's called a helper variable right here. Okay? And so let's say that I have this helper variable called count, which I'm going to use to help us with this. Right? Yeah. Different programming languages can be pretty difficult. Okay. Because what I want to do for this matrix is I want it to look like this. Okay. And so I want this matrix so that, I count 1, 2, 3, 4, 5 on the first row. And the second line, I count 6, 7, 8, 9, 10. And then on the third row, I have 11, 12, 13, 14, 15. Okay. And so to do that, I'm going to use this kind of nested for loop to kind of help me out. Okay. And so first, I'm going to have an outer loop for the row. And so this is a loop that's going to loop over all the rows in the matrix. And so since this matrix has 3 rows, I'm going to loop from 1 to 3 on this. Okay. Then for each row, I'm going to loop over all of the columns. Okay. And so since we have 5 columns in here, I'm going to loop from 1 to 5. Okay. And then what I'm going to do is I'm going to assign values to this matrix according to its row index and its column index. Okay. And so what I can say is that this matrix at row index, and so that's whatever value this guy is right here, and column index, okay, which is going to be the inner loop index right here. Okay. And so that's going to be equal to count. Okay. And so count here starts at 1. Okay. And so the first time that this loop goes, row index is going to be 1 because that's the first iteration of this loop. And then the inner loop is going to start at 1 as well. So we have nested matrix at 1, 1 is equal to count, which is 1. Okay. And so that's what we get right here. And so the 1, 1 entry of this matrix is going to be 1. Okay. Question in the chat. Okay. And so from here, we're going to continue looping on the inner loop, okay? Because remember, when you have nested for loops, the inner loop has to complete kind of a full rotation in order for you to go back to the outer loop, okay? And so the next index for the inner loop is going to be column index is equal to 2, okay? And so once we enter that one, then we have nested matrix at row index. Remember, row index is still equal to 1 because that's the value that's given in the outer loop. So the outer loop hasn't advanced yet, but the inner loop has advanced by 1. Okay, and so we have the nested matrix at 1, 2 is equal to count. Okay, and so at this iteration of the loop, count is actually going to be equal to 2 because we've updated its value by 1 right here. Okay, and so that's how we get 2 in this slot in the matrix right here. Okay, all right. Next, we're gonna keep iterating on the inner loop because the inner loop hasn't completed yet. Okay, and so column index is now going to be 3. Okay, and so we have nested matrix at 1, 3 is equal to count, which is now equal to 3. Okay. And then we keep going to this until column index reaches 5. Okay. And so once column index reaches 5, then this inner loop is done iterating, and then we return back to the outer loop, and then we move on to the next one. So after this reaches 5, then the row in the outer loop here is going to move on to its next spot, which is 2. Okay. Yeah. So when you have nested for loops like this, it can be difficult to kind of follow the logic, but sometimes it really pays to kind of do it kind of line by line and really kind of follow the loops as it goes. Okay. And so the end result of this kind of segment of code like this looks like this. Okay. Okay. Any questions on nested for loops? Okay. All right. So one last thing I want to talk about before we end today is using an if statement in a for loop. So this is kind of combining our two last things. Okay. And so this is a common thing to do. And so this is one thing where you can use conditional programming to kind of manipulate your program. Okay. And so what's common is to basically use an if statement that incorporates the loop index. Okay. And so let's take this example here where we want to write a for loop and assign values to this vector where every even number is given a value of 2. Or we assign a value if the index is an even number. Okay. And so one way that you can do that is we can use this mod function right here. And so mod is the same thing as remainder. Okay. And so when you call mod function in Matlab, it performs a division between these two numbers. So it takes the vector index, and in this case, divides it by 2. Okay. And if that remainder is equal to 0, then we know we have an even number, and then we assign a value to that. Okay. And so the result of this looks something like this. So all the odd entries in the matrix, those still remain 0, because that's kind of what we assigned right here. Okay. Whereas all the even indices are given a value that are equal to that index. Okay. And so the second index is 2, fourth index is 4, 6, 8, and so on. Okay. And so we'll see this a lot where we'll put if statements within for loops where we'll do different behavior depending on what our index is. Okay. Okay. Any questions on this before we sign off for today? Question. Mod, yeah. So mod is a special function within Matlab to compute remainders, and so basically you can call the mod function, and then what mod's going to do is it takes 2 entries. So it takes one number in the first entry, and it takes one number in the second entry, and then it does division by those 2 numbers. But then mod, what it actually returns is the remainder of those two numbers. Okay? And so let's say that vector index here is 5. And so we're going to do 5 divided by 2. Okay. And so that's obviously 2 remainder 2. So it's going to be 2 remainder 1. Sorry. Yeah. All right. Question. So what is the double equal? So the double equal is it checks if it's equal to. Yeah. And so this says, remember, so the body of an if statement is you have to have a conditional. That's something that returns true or false. Okay. And so before up to this point, we use greater than or less than. Okay. But the double equals checks if it's equal to, right? And that's different from the single equal, because the single equal here is assignment. And so when you use a single equal, we say that, this name, this variable is going to be given the value of this, whatever is after the equal sign. Double equals here is a conditional statement that checks if 2 things are the same. Yeah. Yep. Mm-hmm. All right. Any more questions on this? We can revisit this next time, but I kind of wanted to hurry up a little bit because we're at the end. How about on Wednesday, we'll revisit this example, and then I have 2 more kind of more complicated examples for you guys to look at. Okay. Okay. Yeah. So let's call it here for today. Wednesday, we'll pick this up again. We'll finish out these examples just so you can kind of see, and then we'll start moving on to some of the theory in this class, which is finite difference. Okay. So I know I'm a little bit over, so I apologize for that. So thank you guys for sticking around. Thanks for coming to lecture today. And I'll see you guys on Wednesday. Thanks, everybody. And yeah.